presenter, Branislav Tobutsky, and the presentation is combining DVR and UPS techniques for an interruptible supply of ultra-sensitive nonlinear appliances. So please.
Come on.
Please share the screen.
Yeah. Hello?
Okay.
Hello?
Hello. Okay. Please.
Can I start? Thank you, Chairman. Good morning, ladies and gentlemen. My paper, thank you for the introduction. And my paper deals with an application of combined techniques of dynamic voltage restorer and uninterruptible power supply, which makes possible both of the short time watch 6 compensation as well as longer power supply interruption under the simultaneous operation of equipment and the network. That means parallel operation. The combined techniques is enabled mainly using an instantaneous voltage detection, quick bit bidirectional over switches. Also, it needs a very fast control method which can provide a voltage recovery for phase-sensitive loads during several calculation steps, so the deadbeat regulator is used. Such a system compensates even the influence of nonlinear loads on the power supply network. Topics of the paper is normal, and on the end of presentation, I will show you the modeling and simulation results, and also the experimental results. The first slide shows us the block diagram of a DVR restorer. There are normal operation full line and restoring operation dashed line. The next one is the circuit schematics of a DVR. So it's known, I hope, for the more people. And this is the principal block diagram using UPS system. So it's classical, but during the step changes with the over switches between network and UPS, sometimes is problem with transient of the current and voltages. You can see on this picture. When the step change is from 0 up to 100%, this is the problem. So the new concept block scheme is shown on these slides. You can see in the right on this slide. And as I said, the UPS will use the deadbeat controller, this bottom figure. So when we need to substitute of the both properties of DVR and UPS systems, we can, it is enabled, but mainly by the instantaneous voltage 6 detection, quick bidirectional over switches, and the instantaneous, very fast control method of the output voltage, as I said. What brings such a combined scheme? Instantaneous voltage 6 compensation, minimizing of transient phenomenon, and improving of reliability regarding to mean time between failure by some order. So regarding to determination of the instantaneous voltage, we have used the DQ coordinates because in DQ coordinates the voltage is constant. It's written on this figure, and this equation is very clear. Vd plus Vq is the constant. Also, V alpha and V beta is constant also. Okay. So this is the circuit scheme of a VSE inverter used in UPS systems. You can see PWM inverter, LC filter, and nonlinear load here. Nonlinear load, it means that it's a rectifier with capacitive filter. This is written capacitive rectifier. So model of VSE inverter is well known. This is the equation, this model in block scheme. So now we will talk about shortly about current loop control. This scheme, complete scheme, and a simplified scheme is on this bottom figure. As you can see, we have used that bit controller. So transfer function in operator mathematics is shown on these equations, and the transient function in Z transformation is written here. So we can this model of the current controller is very easy, and we have simulation the operability of the current controller. And as you can see, in two computation steps, the current will be regulated. Yes, these main benefits of the deadbeat controller. Voltage control loop is rather complicated, but it's possible also use the simplified control loop in the bottom part of the slides here. But some problem is that the in the numerator of the transfer function there is some zero. After parameterizing, it's here, and this is show that the compensation of zero of transfer function is used at this block scheme here. So then we can the final transfer function you can see here, and the denominator compared to the standard second order transfer function here. So by comparison, we can determine the gain of the transfer and also integral integral time constant here. We can use also dot relation here. So after this, we can simulate the whole system's new concept. So this is a simulating model of VSE with LC filter and nonlinear capacitive rectifier here. And this is system parameters and control system parameters here. Output power, switching frequency, and so on. Load. So now I can show you the result. This experimental parallel operation of the new UPS devices with network. So you can see the current from network, current from UPS are in parallel is the same, 50-50%. The next simulation results show the grid network disconnect in the maximum voltage, resistive load, inductive load. So this is simulation. During simulation, that bit controller is a very fast activity. You can see here in the time 0.045 milliseconds here and here. The next figure shows the change of the load from 0 up to 100%. Linear resistive load, there is the simulation, this experiment. You can see that experiment is very similar to simulation result. Grid disconnect is in this time, as in previous, in this 45 milliseconds about. The next is linear inductive load, and also the from change load change is from 0 up to 100%. So it's simulation result, experiment result here. And I think it's the last simulation and experiment results. So this nonlinear load, parallel operation grid and the new UPS concept system. So you can see in this time, as previous in 45 milliseconds here, the grid is disconnected. So the voltage is slightly disturbed here, but THD total harmonic distortion of the voltage is very good, is about 2%. This after disconnected this network of the. So this is the conclude of my presentation. The combined technique of dynamic voltage restorer and uninterruptible power supply, providing compensation for the short-term voltage shifts as well as longer network interruption, have been shown. Comparison of simulation and experimental results show a good agreement and a good quality confirmed also for nonlinear loads. The difference between the measured and simulated waveform reaches just 2.15% regarding to THD, total harmonic distortion. This all is enabled mainly by instantaneous voltage detection using DQ method, quick bidirectional overswitches, and very fast, nearly instantaneous control method of the output voltage. So it's all of my presentation. Thank you.
Thank you. Well, actually, Mr. Chairman was disconnected because of the problem in electric engineering area. Something went wrong with electricity, and somebody tried to interrupt our session. So, what would you suggest for conference participants and for users in case they avoid longer interruption, around 1 or 2 hours? If we have something wrong, something bad with electricity, with power supplying.
Okay, I think that you should continue your role as a chairman. That's okay.
Yes, so definitely, it is not a problem.
Yeah.
So, do we have any questions from participants?
May I have a questions? One?
Yes.
That's really good, very interesting paper and good approach to this. That's very important things, particularly in the very sensitive nonlinear loads. Have you already applied for electrical motors of some your devices to check if everything is okay? if, for example, if frequency is being changed, since we have sometimes in the mining industry, we have electrical motors with regulation of a speed, and the frequency is very low. What about this, if the frequency is low? It will work efficiently or no?
I think it's possible. The frequency, you can see on the experiment, the frequency is still the same as previous after the grid connection. So it's possible to connect also some synchronous servo motor and so on.
Okay, thank you very much. Thank you very much. Very interesting.
Thank you.
Okay, thank you for the presentation. And I would like to invite the presenter. We have subscription. The presenter will be Gergana Vacheva, and the presentation is named Mathematical Model for Determination of Energy Cycles in EVs, electrical vehicles. Yes. So
thank you. Thank you, Mr. Chairman. Just a second to. Okay, is it visible?
yes, just press
okay.
Excellent.
So my name is, thank you. My name is Gergana Vacheva, and today I will present you our presentation, which is entitled Mathematical Model for Determination of Energy Cycles in Electrical Vehicles. I'm from Technical University of Sofia, Bulgaria, and so today we will present you this title, a short, brief one of the presentation. I have some introduction, the mathematical modeling, the results, discussion, and conclusion of this paper. So as an introduction, as you can see, the electric vehicles are those who the main energy source, it could be fuel cell or rechargeable battery or supercapacitor. They are increasingly used in accordance due to the increased environment requirements. This is a result of progress in the field of mobile electricity sources and the use of efficient electronic converters and control systems. For technical and financial reasons, the number of electric vehicles is significantly smaller than those which is powered by liquid fuels. And this is the main reason for the research of this problem, which is the high cost of the battery, the hydrogen components, and the supercapacitor, and also the lack of the infrastructure for charging electricity of hydrogen. Here is presented the table 1, in which is the characteristic of the used in this paper electric vehicles. Here we have a Nissan Leaf and Tesla S, which is provided by the manufacturer. And here you can see the different parameters, the years of the when it's produced, the different type and the electric vehicle aerodynamic coefficient, which is a little bit changed between the two electric vehicles. So the rolling resistance, the mass of the vehicle, and also the mass which is produced by the different cycles, driving cycles, which is provided by the European Commission, and also the torque, maximum power, maximum speed, which can be obtained by the different type of electric vehicles, the gear ratio, which is used, the friction coefficient, and also the wheel dynamic radius of the tires. And here we used, which is one basic equation. This is the mathematical models, which is implemented in MATLAB Simulink, and we used this equation to calculate and verify the obtained data, which is provided by the manufacturer. Here we have equation which describes the dynamic of the vehicle movement. So this is the second law of the Newton. Here we have the velocity, the aerodynamic force, friction force, and traction force. So here with this equation, we calculate the tractive power, which is FA, it is necessary to take into account the maximum torque of the vehicle and also the maximum power and their limits. So here in this equation, we have some limits, which is about this. This limitation will be considered further, but in both cases, it's necessary to make additional check that the traction force is less than a DC force between the road and the vehicle. And here we have some constraints, which is presented in figure 1. Here we have the curve of the maximum force of electrical vehicle. So here we have some constraint by maximum power and some constraint by maximum moment. The first one defines the line when the maximum moments become equal to constant, and the second one defines the maximum power. So here we have the speed, which is the switch speed, and the maximum speed that we can obtain. Maximum traction force is applied to achieve a maximum speed of 10 seconds. At this moment, the pulling force is limited by the speed. After reaching this speed, we will go destructive force, and after that is limited by the condition of maximum power. So here is the question that describes this constraint. With these two limitations, we get the switching speed, and the maximum tractive force is described with these two constraints. For when is minor than the switching speed, and when is constrained by the power of the electric vehicle. So here is the model which is realized in MATLAB Simulink. So here we can obtain we can calculate the acceleration, the velocity, and also the road, which is the distance of the road, which is made for these 10 seconds. And here is presented the results. So we have the traction force with Nissan Leaf. Here we can see that we obtain about 4,200 newtons, which is the force. And here in the second figure, you can see the curve which describes the acceleration, which is obtained for this power, just for the time which is nearly close to the that which is given by the manufacturer of this type of electric vehicle. Here we have the velocity, so the speed, which is from 0 to 100 km/h, and also the distance for this 10 seconds is presented. And here we are made our results with a reference of two driving cycles. We used as a reference VOTC, which is class 3 and also class 2. This is a test procedure which is provided by the European Commission, which is used for evaluation of fuel consumption and carbon emission. Here in the first figure, we can see exactly what is the time and this type of procedure. So here we have multiple acceleration and braking modes for the time of 1,800,000 seconds. And here we can see the acceleration which is obtained for exactly this type of cycle, and also we used this type of cycle to make some evaluation of the power of the electric vehicle, the electric motor, with this equation. So we have the energy, and also here is for this type of cycle. Here is presented another one, which is similar, but you can see we have, this is class 2, and we have a different profile of the acceleration and braking mode. And so you can see that we obtain different results for the acceleration and also for the power. And also we made some calculation of with this method, with the previous equation. We calculate the total energy which is used in this type of driving cycle. And as a discussion, I can say that with the accomplished research of the dynamic of the electric vehicles, which is simulated with different test procedure, it can be observed the total sum of and energy in the presented scenarios. And there's a significant difference about the two of them. The duration of the test procedure is also with a different time. It can be observed that the second scenarios, the maximum velocity significantly decrease. These reasons lead to the conclusion that the different test procedure has high influence to the total energy which is produced by the electric vehicle, the energy that can be stored necessary for the design of the system of power converters, and also with the management of energy storage devices for providing the adequate operation of the entire propulsion system. And as a conclusion, I can say briefly that the realized mathematical model of mechanical structure of electric vehicles provides the study and research of multiple operating modes, such as accelerated a vehicle dynamic mathematical model. The maximum speed is achieved through a more in-depth study of vehicle performance, and the consideration of each subsystem constituting the structure of electric vehicles would help to create a model which describes the different modes of operation, and with defining the selection criteria for converters such as input voltage, output voltage ripple, wall current ripple. Rating frequency of the converters helps to determine the operating modes of the wall loss converters, which leads to increasing the millage. And on the other side, the type of test procedure has significant influence of the energy demands of electric vehicles. And with improving this methodology, represent.
Thank you for the presentation. Oh, it seems okay. The presenter is still connected. Okay. So
I'm sorry for.
Sorry, we didn't hear you clearly. Okay. Do we have any?
Do you hear me, dear Darius, now?
Yes. Yes, everything is okay.
Can I continue with the chairing of the session?
Yes, yes.
Okay. Dear Gergana, thank you very much for your presentation, and sorry for my absence for the first two presentations.
It's not a problem.
How goes the thing now with questions? Somebody of persons who is online can ask you somewhat related to your work. No questions. Thank you very much, Gergana. We will continue with
questions. Maybe I can ask one question, okay?
Yes, yes.
What about experimental verification? Are you going to somehow to apply it, or just do you have any plans somehow?
Yes, at this time we are not finished, but we have plans to use the two motors, which is traction motors, with two different DC converters. One of them which is bidirectional, and the other which is in the one side. And also to use a supercapacitor and the fuel cell as two dependent sources of for supplying the electric vehicles, and also to use the supercapacitor for storage the energy when during braking to regenerate the different time. But at this moment is not finished also the experimental
I see. Okay.
issue. Thank you.
Thank you very much for question and for the response. I think that was all. We will continue with the next presenter. The next presentation is evaluation of gallium nitrogen power transistor switching performance on characteristics of bidirectional DC-DC converter. And this paper will be presented by Michal Frivalski. Is presenter online or no?
Yes, I'm here.
No. Welcome.
Hello. So I have started to share my screen.
Welcome. Take your time and good luck.
Thank you very much. So my name is Michael Frivalski, and I'm from University of Žilina, Slovakia. Here we are dealing with the investigation of the power transistors from the evaluation of the switching performance point of view. And this research is also applied research, because instead of the evaluation of the switching performance, we also provided the implementation of the tested device within proposed DC-DC converter. So the content of the paper is as follows. So at the short introduction, we are discussing the evolution of the silicon transistors up to gallium nitride technology. Then we are discussing the influence of the switching frequency on the amount of the switching losses of the given transistor type. What we have done and how we deal with the experiments, we have used very precise Pspice simulation models. So we have been, it was possible to investigate the losses very quickly. And in the final, we provided the experimental verification of on the proposed bidirectional buck-boost converter. So, as I mentioned, we have selected the gallium nitride transistor type. I will skip one slide, but then I will go back. So this transistor is from the GaN technology company. They are using enhanced mode gallium nitride technology with the patented technology of the package. So on the left side, you can see the structure of this transistor, and on the right side is the parameters, the main parameters. So the transistor is suited for blocking voltage of 100 volts, and this will be enough for the target application, because the maximum is 24 if the boost mode of operation is considered. Also, you can see that given transistor type allows high current rating, and this is due to fact that it is a transistor which is suited for automotive segment. Very important issue during the design of the gate driving system is these parameters. So the gate driver must be able to provide also negative gate voltage. So it is a little bit tricky to design such driver. Here you can see the evaluation of the switching energy on the value of the switching current, while both turn on and turn off energy are considered, and the characteristics are a comparison between experimental measurements and the simulation of the switching performance. So here it is confirmed that the simulation model, Pspice simulation model, has a acceptable accuracy, and for the parametric investigation, it is enough to provide the simulation. So you do not need to make a test stand in the laboratory and make the measurements if you obtain or if you have such precise and accurate simulation model. So therefore, we have decided to evaluate in parametric way the switching losses for the hard switch commutation mode. So there is no resonant switching. The circuit topology in Pspice is shown here. So as a blocking diode or freewheeling diode, we are using very fast Schottky diode. So there is no reverse recovery and there is no influence. You can see it here on the turn on performance of the transistor. This is the simulation model and the equivalent circuit of the evaluated transistor, and the parameters that have been has been changed are transistor current, switching frequency, and the voltage. There are two levels of the voltages because in one mode the converter operates as a buck converter, in the second one as a boost, so therefore two values. What is interesting is the values of the switching frequency. You can see that we have been testing almost 700 kilohertz of switching frequency, but this is normal if the gallium nitride transistors are considered. What is unwanted effect? You can see it here that there is a high voltage ringing during the turn off of transistor, and the value exceeds the allowable level of blocking voltage, which is shown in datasheet. It can be caused due to parasitic inductances within the circuit. So therefore, in practical applications, it is good to use some snubber circuit to reduce these spikes and to prevent transistor from any damage. So we have provided the parametric evaluation of the switching losses. So here you can see that there are turn-on losses and turn-off losses. The value of the frequency was changing, and also the value of the current. So it is natural that for the high currents, the losses are the highest. Also, the switching frequency is increasing the total value of the losses. What is interesting here is that the total losses for lower frequency, 500 kilohertz, is higher than for the highest frequency, 700. So from this result, and for 12 volts of the supply voltage, we can conclude that the gallium nitride has also a very good performance if the high switching frequency operation is required. The same tests have been done for 24 volts, and the results are also very interesting because we are reaching very good performance for the highest switching frequency. So here is the 300 and 700, and there is a very, very small difference. If we compare these results for the 24 volts and 12 volts, we can see that the supplying voltage does not affect as much the total value of the power losses. So the voltage does not have direct impact. The main impact is provided by the current and switching frequency. So now we have some overview in which, let's say, power loss level the transistor can be operated. And then we have implemented these transistors in a proposed bidirectional DC-DC converter. So the equivalent circuit is shown here. So in one mode, the converter operates as a buck, in the second one as a boost. The converter was designed for a nominal switching frequency of 500 kilohertz. These are the output or input-output parameters. And the nominal power was 120 watts. On here you can see the experimental prototype, and the nominal frequency of 500 kilohertz is mentioned here due to design of the inductive elements, so the inductors or filtering capacitors. The proposed module consists of two boards. The horizontal is a motherboard, so here there is implementation of the control circuits and monitoring circuits, and the vertical one is the power board. There is a small heatsink located on the transistor, so there is no forced cooling, just the passive cooling. And here we are showing the experimental test stand. So for the evaluation of the efficiency of proposed converter, we have been using a spectral analyzer, and both boost mode and buck mode was verified. You can see that the converter is achieving almost 97% of the efficiency up to the 50% of nominal power. And for the nominal power, it reaches 95% of efficiency. So this slide is showing the same results, just in a better scale. And what was confirmed, if the simulation analysis was provided, you can see that this curve is valid for 300 kilohertz. And for the higher switching frequencies, the converter has a much better efficiency. So this confirms also the fact that the GaN power transistors are suited for very high switching frequencies. So it is possible to improve the power density of the converters. So I think that that's all from the presentation, and I am open for discussion. Thank you very much.
Okay, thank you for your presentation. And for this, how to say, nice work.
Mm-hmm.
Are you online,
Yes.
Michael?
Yes, I'm here.
Yes. Okay. Do you hear me? I think about that.
I can hear you, but
any question from other attendants of this group? No question. That's all, dear Michael. Thank you for the presentation. Have a nice day. Bye.
Bye-bye.
The next presentation comes from China. The title of the paper is Exploration, the Disaster Source of Mine Water by Electromagnetic Radiation. And this paper will be presented by Ben-Yu Su. Do you hear me?
Yes, sir. Is okay? Hello? Is okay? Hello? Hi. Good morning. Good morning. Hello?
Yeah. You can start your good morning, of course. Do you hear me? Do you hear me?
Thank you very much. Yes.
You can start your presentation.
Okay.
Welcome, please.
Much. Okay. Good morning, everyone. The title of my presentation is Exploration Disaster Source of Mine Water by Electromagnetic Radiation. My name is Ben-Yu Su from China University of Mining and Technology. And my report outline totally contains 3 parts. The first one is the introduction of my research. The second one is my main research content. And the third one is my conclusions. And first one is the introduction of my research. Because the name of my university is China University of Mining and Technology. So here, the education and research focus on coal mining. However, mining safety is the first position. And generally speaking, in the coal mine, we have the following natural disasters. The first is the gas outburst and explosion. The second one is the coal dust output and explosion. And the third one is the mine fire. And the fourth one is the mine water flooding. And next is the roof exchange and rock outburst. And because in our university, we have different research team for research different natural disasters. My research team works focused on mine water flooding. The reason is that because as shows the figure, because the pressure of the earth is very high on the ground surface. So once exchange of the water flooding happens, it will flood the whole coal mine tunnel during a very short time. So it usually results in serious casualty of mine lives and property loss. So this is my research purpose. And currently, and we have 2 masters popular in the coal mine for detecting mining water disaster. The first one is transistor electromagnetic master. And before in the maybe 2007, I do the report about 2 masters. The first one is TM master. This is the tunnel. Now this is the tunnel, and we put our equipment here. We can detect the geological information from different directions. And from those geological information, we will transfer those information to the resistivity of the coal mine. So this is a figure shows we detect the distribution of the resistivity in the coal mine, and usually low resistivity means it's water. So we can tell the mine, the geologist, maybe here is the water. They will using the other technique to make sure where water where it is the water. And the second method is the direct current method, and this is the tunnel. And we put the electrodes in the tunnel. By measure information, we can use those information to know if random of the heading geological information like here. So this is our our research result. This it means here geological information is here. So from those information we know if random of the heading where is the geological information. So this is two methods is very popular, and in the coal mine, our research team usually use those two methods. But today, I want to introduce another method. This is the geology models, and this is the COSIM, because this is the tunnel. Because usually when we cutting or drawing the coal mine, usually here or here will broken zone will formed, and those broken zones sometimes will develop into the mining water conductor path. So it is very dangerous for coal mining. And this is the first one. And the second one, because during the formation of those broken zones, here will produce electromagnetic waves. So so the purpose of our research is we try use the information from here to detect the coal mine geology information. And for example, this one, if some brick zone developed into like this, it will conduct the mining water, and it will result in the mining water flooding. So it's very dangerous. So next is my research content, and because this article purportedly is for theory research, so we use the forward modeling and the inverse modeling to show my research is it can be used for detect the mining water disaster source. Generally speaking, because this is a transistor, and this is the geological anomaly. So so this figure shows the electromagnetic propagator in the medium, and EI like this, EI, HI, and EI, it means the incident wave, and ES and HS indicate the scattering wave. In fact, the electromagnetic wave exists in the medium with the form of the total wave, which means the total wave contains the incident wave and the scatter wave. Based on those ideas, we can use those formula, and finally, we will not interpret it in detail here. And finally, we will get this formula like this one. And my research for calculating the electromagnetic wave using this formula. And this is a simple model, and because during the formation of the break zone, like this one, it will produce electromagnetic wave. Here we use 16 electron dipoles to stimulate the flux zone, produce electromagnetic wave, and this is the modeling result. So we compare those two, and we can see this formula can match this model very well. And this is a simple model. In fact, in combine, the model, the geological model, maybe like this one. This is the tunnel. When we combining, and it is possible in front of the heading, there will be a coal rock flux zone will be found, and here, in fact, in my simulation, I how to say, this one can be say the transistor. It may be here. It will produce the electromagnetic wave. And then this is the model result. So we can compare two. This is model. This is electromagnetic responses for this model. So we compare two figures. We can see it match very well. In fact, as I mentioned, because this flux zone also it can produce electromagnetic waves. So we try use this one to detect other electromagnetic anomaly bodies. Like this one, if here is a water bearing zone, maybe the water bearing zone is here. So we can calculate the responses, electromagnetic responses, this one or this one. So we can say, how to say, geology, electromagnetic geology models, coma geology, and is very sensitivity for those electromagnetic waves. Based on those formula forward modeling, so we can build a function like this. And this is one is we think is observed data, and this one is theory calculation values. So we can use这个 mathematical method to get the arbitrary solution. It means we can from this iteration, many times iterations, we can get the distribution of the common geology electro is dielectric is we will get the solution arbitrary solution. A solution, it means is the distribution of dielectric constant. And last simulation like this one. This is the model. This is cosine. This is cosine, and this is the flex zones, and this is the forward modeling. And we calculate use this one, and by the how to say, by this function, we will get the distribution of the electric constant. So we can compare this to figure. This is my inversion result. This is the models. So from this one, from this inversion models, we can guess the distribution of the dielectric constant. And this result is our research, another team, they work used now. Our method compared with this one, we can locate the geology anomalous bodies in the command, but they just get the how to say get the get the responses. So my master is good, is better than them. So next is my conclusions. The first one is that this is a model. This is a forward modeling. So scatter electromagnetic field responses is very sensitive for the coal mine geology. The second one, because this method from the other authors' research, but they use the smaller scale. But my research can use the a large scale. And the third one, compared with the method from the China State Tier level of the coal resource safety, my research can locate the disaster source processively. So my method is maybe is better than them. That's all. Thank you.
Thank you very much, Mr. Su, for your presentation. We spent a little more time that was permitted, and we will continue with the next presenter immediately, without question. Thank you for your interesting presentation and work.
Thank you very much. Sorry.
Have a nice day. Bye. And the next presenter comes from Poland, and the title of the paper is Subjective and Objective Quality Evaluation Study, presented by Grzegorz Mieczysław Debita. Do you hear me, dear Mr. Debita? Yeah.
Okay. Hello. Hello. Can you hear me?
Okay. Take your time and welcome.
Okay, Mr. Chairman, thank you very much. The title of the presentation is Subjective and the Objective Quality Evaluation Study of BPL-PLC wired medium. The outline of the presentation is the short introduction to the problem, objective evaluation tests, there will be something about the noise measurement, narrowband transmission, BPL bidirectional voice transmission, and the subjective evaluation tests, and the last point is discussion and the conclusions. First of all, the BPL-PLC technology is an alternative way to methods to use in signal transmission. The main advantage is the low cost of this application, because we can use the existing infrastructure to create the telecommunication network. Some problems is that the one to the node in this technology is in general sensitive to the environmental electromagnetic compatibility interference, but included. We are make some application in BPL-PLC frequency range from 2 to 32 megahertz in a main medium voltage, the middle voltage network. It can to use not only to control environment condition, but most of all as a voice or image transmission medium, included so-called last chance in case of tilts and the mine disasters. In the fact, the middle voltage cable networks are theoretically the most resistant to mechanical damage. In this work, we have the test results of the signal transmission efficiency correlated with the effectiveness of bidirectional voice transmission in 6 kHz mine cable network using the BPL technology. The measurements, both narrow of the half to 15 megahertz and broadband 2 differential modes frequency range, 3 to 7.5 megahertz. Tests were performed for both inductive and capacitive inductive coupling with measuring devices for PLC BPL cable modems. The test regarding the signal transmission efficiency in the middle voltage mining cable were carried out under real-time mining operating condition, taking into account bound noise level in the cable and its loading with distorted current waveforms. The effect of the powering the cable on non-linear loads being the source of higher harmonics of both current and voltage was also explained. Firstly, we are make the noise measurements with two methods. One method of measuring the value of the waveforms level in the cable under non-linear load that show in the figure on the next slides. We are test carried out the both capacitive and inductive coupler installed on the cable supply in the point A in the mining. In this case, there was a spectrum analyzing and the resolution bandwidth was less than 1 Hertz. And during the tests, the cable supplied non-linear mining loads. For example, the motors with frequency converters. The effective value of distorted current was the approximate 18.4 amperes. And the harmonic content, third, fifth, seventh, and 11th in voltage was relatively small to that DHD value was with on half to 20.7%. And we will see that we'll see on the slide that is the picture where we have the spectrum analyzer on A is connected to the capacitive coupler, and on the second situation, the spectrum analyzer was connected to the inductive coupler, and that is the noise measurement for the first picture to the capacitive coupler, and that is for the inductive coupler. Next step was the narrowband transmission. The configuration for narrowband transmission that will be shown to the next figure, to the figure to the next slides. The input signal frequency in the half to 15 megahertz range, with a constant amplitude of the 10 dBm power was injected from the generator We are make the measurements in this connection. The first was the spectral analysis was connected to the capacitive coupler and the signal generator to the injective coupler. And the second situation was that the spectral analyzer was to the inductive coupler and the signal generator to the inductive coupler. And the results, the blue one is for the inductive coupler, and orange, red one is for the capacitive inductive coupling results. And we are calculated the attenuation factor using the model. We are model all the cable for the two aspects, to inductive coupling and for the inductive and capacitive coupling. The first is for the inductive coupling. A second is for the inductive capacitive coupling. And we will see that the calculate attenuation is very closely to the measurement. And the last type of experimental was the BPL bidirectional voice transmission. We haven't specified the highest efficiency of the narrowband transmission for the test type of the medium voltage for 6 kilovolt cable. And we are used the frequency range between 2 and 8 megahertz. We are used two different modes using OFDM cable. Mode number 1 was from 3 to 7.5 megahertz, and mode 11 from 2 to 7 megahertz. And the test was carried out in an arrangement, and in the figure on the next slides, we will see for both capacitive and inductive coupling and inductive coupling for the BPL PLC transmission. And now we will see that how the network look like. The first is the master gating. The modem was connected to the capacitive coupler. And there was the voice transmission server with the computer, and the slave gateway connected to the inductive coupler with the microcomputer as a client. And the second situation is we have changed in the coupler, and we connected the master gated to the inductive coupler. And the results are shown at this table. The approximately bitrate transmission was for the mode 1 from 23 from 8 to 23 megabits per second. For mode 11 was 11 to 34 megabits per second. We can see that the transmission is not symmetrical. And we make some experiments, this subjective verification, compare the objective simulation and the measurements results in performed by the human individuals. To subjective assessment was carried out using biodynamic custom one handphones, and invited the group of 15 people aged between 25 to 35 years old, and the note of them had hearing distorted. each individual assigned that the quality individual in 5-step of mini opinion score, and objective differentiated grade. That was the scale that you see at the table, how it looked like. And the result of the subjective quality evaluation, including speech samples in the British English, German language, Polish language, and all is shown in the next figure. It should be noted that this result have been arrived at from the both communication direction, from the point A to point B, and from the point B to point E. And we'll show for the, we have the samples processed for the 8 kilobits per second. We will see the objective difference grade. If we change to the 16 kilobits per second, we have the better results, and the most better results is for the 24 kilobits per second. And something about the tests. When it comes to the background of tests, individuals, it is want mentoring than the each one. The Polish was the mother tongue, where both English and German was the second language of choice, and microever participant pointed of the sequences spoken by a male lecturer seemed more applying. In our case, due of the profile of the mining industry, the feedback becomes an important factor. And the conclusion, as shown that on the presentation for the BPL communication, transmission can be effectively used in medium voltage cable networks for data transmission, especially voice communication, considered as so-called last chance in case of hazards and mine disasters. Such networks are theoretically the most resistant to mechanical damage. In order to provide high effectiveness of the BPA PLC transmission, particularly understandable voice messages, one needs to know to overcome the influence of the environmental interfering electromagnetic field, electromagnetic compatibility factors. Furthermore, the use of the effective coupling with the cables is on the great importance. And describe this test carried of the 6 kilovolts main cable line of approx 300 meters long have shown that the effective length of the bidirectional voice transmission for both rate electrical cable operating condition as well as under extreme condition remains practically the same. We can see that the analysis show the speech signal at the lowest bit rate, 8 kilobits per second, provide to be insufficient in order to provide clear and unambiguous statement. Only in case of 24 kilobits per second, the voice transmission was clearly understood and acceptable. Similar results we are found with the having type of the coupling or node. And that is all. Thank you for attention.
Hello, Professor.
Hello, Professor.
Probably something went wrong with the computer or electricity again.
Okay. Okay.
So does Does anyone have questions? Okay. So if there are no questions, so I would like to invite the next presenter, and it will be Michal Pipiska. And the name of presentation: MOSFET gate resistance influence of voltage imbalance of two-switch feedback converter. So please.
Hello, can you hear me? Hello?
Yes, yes.
Okay. Hello, my name is Michal Pipiska and I'm from University of...
Full screen.
Yes, wait. Presentation. Yes. Hello, my name is Michal Pipiska and I'm from University of Žilina. This article deals about the two-switch flyback and some problem with imbalance of voltage on transistors. This is a part of our students, which is diploma thesis. So at first, they must design some converter which have this parameter: input voltage range 120 to 650 volts. The output voltage is symmetric, 15 volts, or 30 volts non-symmetric. The output nominal current 1.67 amperes and output power 50 volts, and switching frequency around 100 kilohertz, and required efficiency 9%. For a good choice of topology, we looked at the table, and here is some parameter, and our best choice for our design is here, where payout is lower than 100, input voltage is higher, and then 400 volts, and output current is lower than 5 amperes. We can see that we have a two choice: two-switch flyback and two-switch forward, but a better choice is two-switch flyback because two-switch forward is little cost and little complicated. So at first, I would like to explain how two-switch flyback work. In first interval, which is accumulation interval, is the transistor open, and the energy from the input is stored in the transformers, because on the second side voltage is in opposite way, so is blocked by diode, and in this interval is accumulated the energy to the transformers, and the energy to the output going from the output capacitor. Second interval is the accumulation interval, when the energy from the transformers go through the diode to the output capacitor and the output. In this state is transistor off, and the voltage on this transistor is divided to the same value, and the value is input voltage plus reflected voltage, and divide by Q, and that is voltage on higher transistor and lower transistor. This voltage is theoretical same. Here's some simulation where is power stage and control stage. Here is a regulator, and here is transistor free-wheel diode, and transformers, output diode, and output filter and output. The result from the simulation is here, and you can see that the voltage on transistor is the same, and this is theoretical, but in practical is little different, because there is some parasitic capacitance of transistor, some leakage current, and ATC parameters, which create imbalance of the voltage. So one of the best choice of driver is here, when we use for driving transformers, and these transformers driving the both transistor in same time, and in this case it's not you have the same time, same switching time. So when come impulse from controller to the input, this transistor is open, and the energy going through the primary winding to the ground, and the impulse going to the secondary side, higher and lower transistor, and this transistor is open through the gate resistance for open. And when the impulse on the input is 0, this transistor is open. This transistor is open, and the voltage is will go from here to the supply, and the voltage on the second side is in opposite way. So this voltage is on this diode, and this voltage dissipation open this transistor, and this power transistor is switching off through this gate resistance. This driver provide the same time for open and closed, but this is still little problem because this transistor is in real not same, as have a little different parasitic capacitance and ATC. Here is designed converter. As you can see, here is input filter, driving transistors, higher and lower transistor, transformers, output diode, and output filter and out. You can see that if we use the same value for off-gate resistance, the same value, the result is different. That here is, you can see that here is drain source voltage and here is input voltage. So if when we changing input voltage, the voltage on higher and lower transistor is different, and this cause different dissipation, and this cause higher temperature on one transistor because have higher power losses. And this happened when the resistor was the same. You can see that the lower transistor have a higher voltage in off state because it's little faster. So you can see here some waveform on transistor in off state, that you can see that a lower transistor have higher value, and it cause that is faster than higher transistors. So we make some experiment, and we change the lower resistance to the higher value, and this transistor make a little slower. In this way, we change the lower gate resistance to the 39 ohm, and this cause that the voltage has swap. So on higher transistor is higher voltage than lower transistor. So around, I think, 200 volts, and this Q a bit. So we make another experiment, and you can see here the voltage waveform on higher and lower transistor, and we make some next experiment, and we change the value of gate resistance of lower than the 30 ohm, and you can see that here is difference between voltage around 30 volts. So you can see that this is a little not same, but it's better than in first case or second case. So in this case is power loss is little in same, but with different, but with little different. You can see here the waveform of in this case that the voltage is same. And here is full power and maximum input voltage. So you can see that here is in discontinuous mode that the voltage going to oscillation on drain source. Here's a thermal performance. So you can see the transistor have same temperature. If the power losses on one transistor will higher, the temperature of one transistor will be bigger, and that can explode or damage of the transistor, because that transistor will higher the temperature than in datasheet maximum temperature. And that's all for me, and thank you for your attention. Hello? Is there something? Someone?
Okay, probably Chairman. Yes, he has some problems. So unfortunately, he won't be able to complete. So I would like to ask if somebody has any questions from the audience. So if no, so we would like to thank you for the presenter, and session is finished. Yes. So thank you for all presentations, and thank you for attending the conference. Maybe next time we will back to more convenient form, yes, of the conference, as it was usually.
With another virus.
Also, if you hear me, thank you, and sorry for these breaks from my side. I had a lot of problems with electricity supply, and now with internet connection and with everything. Thank you to everybody.
Thank you, Mr. Chairman. Bye.
Thank you.
Thank you very much.
Thank you. Have a nice day.
Have a nice day.
Thank you. Have a nice day.
University of Technology, and I will chair the section 2B, System Engineering, Computer Technology. We have 6 presenters, but now we have only 4, but we'll start our session. For every presenter, the time for presentation at overall will be 15 minutes. So please try to present your work in 12 minutes and leave about 3 minutes for discussion. The first presentation is graphic library optimization for MIPS architecture, and Teodora Novkovic will present that work. So please, Teodora, share your screen and present your work.
Thank you. Hello, everyone. Welcome to my presentation. My name is Teodora Novkovic, and I'm from Novi Sad, Serbia. I'm a teaching assistant and a PhD student on the Department for Computer Engineering and Communications at the Faculty of Technical Science in Novi Sad. This paper was written together with my colleagues, Željko Lukac and Ivan Kaštelan, also from Faculty of Technical Science, and Petr Ivanovic from RTRK Novi Sad. Before we start, I would like to thank you all for giving us an opportunity to present our research work at this conference and also in the journal. Firstly, this is the overview of our presentation. I'm going to make an introduction in order to define a relevant problem and motivation. Then I will present MIPS architecture and instruction set. After that, I will present the main idea and our optimization approach. Afterwards, I will show some slides containing the evaluation results. And finally, at the end, I will bring some conclusions and future work. Our motivation is based on one of the problems of embedded system design, for example, how to make software efficiently run on the US processor. The aim of this paper and research is to analyze the efficiency of the compiler-generated code for the BNG graphic library and to present results obtained by optimization for MIPS architecture for real-time operation. The official graphic library that is used in applications for PNG image processing is libpng, and it supports almost all of PNG's features. This graphic library depends on zlib library that is used for data compression and decompression. libpng has significant potential for SIMD acceleration due to the type of data and operations performed during the image processing. In this work, we use MIPS 3274K core, and it is the first member of family of 32-bit RISC CPU cores. And as you can see in the figure, the platform can have optional or configurable parts, which are shown in green. And also, this core contains a load store units and separate data paths, and can execute up to 2 instructions in parallel. The data path contains 32-bit arithmetic logic and multiple divide units. These processors can be found in set-top boxes, voice over IP systems on chip, networking equipment, etc. And this course supports 2 instruction set extensions, but we will focus on DSP-AC revision 2. This instruction set is used to optimize the performance of signal processing and multimedia applications, and has computational support for fractional data types, SIMD, saturation, and other operations commonly used in DSP applications. The MIPS 32 DSP-AC instructions can be classified depending on the implemented function, as you can see in this table. Some of these instructions do 2 or 4 mat operations at once and can be recognized by names that include .ph or .qb. First phase of our work was to find the bottlenecks of the PNG graphic library, and this involves analyzing of the existing code, data structure, profiling analysis, and executing all existing tests before optimizing the code. We used following steps to do graphic library optimization. Firstly, we did software model partition and performance estimation in C. In this step, we examined the underlying data types that the program operates. For example, how many bits are there in a single data element, and can multiple data elements be packed into a 32-bit register for SIMD data types. Afterwards, we worked on performance analysis, better known as profiling. This analysis identifies parts of the program that are suitable for optimization, both of execution speed and memory usage. It is necessary to know which parts of the software solution are most often executed, because there is no point to do some optimization of routines that are rarely executed. Performance analysis shows the number of processor cycles required for each function, thus calculating its occupancy. We used OProfile tool for profiling analysis and to find functions that take the most time across the whole system. This is an open source project that includes a statistical profiler for Linux systems. In this work, we used GCC compiler on Linux operating system to translate the libpng graphic library and run on MIPS architecture. This compiler provides options like MDSP and MDSPR2 that enable the availability of revision 1 or revision 2 MIPS DSP-AC instructions. There are a few methods of utilizing the MIPS DSP-AC that are supported by the GCC GNU assembler for MIPS course, and we use some of them. Firstly, we tried to use auto-vectorization using the specific compilation flags like MDSPR2, O3, and EL for Greenlandian. The advantage of auto-vectorization is that the compiler can recognize scalar variables in order to utilize SIMD instructions automatically. Unfortunately, this method failed to get good results for all routines, so we decided for handwriting inline assembly. Using the inline assembly can reduce the number of instructions required to be executed by the processor, and it is possible to do partial optimization for speed critical section of code. It is generally necessary to make modifications to the program structure, data structure, as well as to do loop unrolling in order to prepare the original code for vectorization and optimization. In order to do better optimizations of routines, a few specific and important tips and rules need to be followed. It is necessary to know the basic latencies of instructions and also usage of out-of-order execution, which can automatically reorder instruction to more efficiently pair up instruction for parallel execution. It is important to know that the MIPS CPUs cannot deliver loaded data to the immediately following instruction without a delay. And also, instruction following a branch is always executed. Also, there are special forms of branches called branch likely, which execute the branch delay slot instruction only when the branch is taken. All of these tips and rules were used to reduce program and data space and to rearrange data space by manually modification of the assembly code. Regarding optimizations, our goal was to reduce the number of memory accesses and to do as many operations as possible in parallel to get the best results. This is derived by taking 32-bit value from memory instead of taking 8-bit or 16-bit values. And compared to the original software solution, they avoid unnecessary memory access up to 8 times within a single loop pass. We analyzed the original source code with an object dump tool that generates assembler code from the source C code. And in this step, we identified where the delays occur in existing the instructions. In addition, instructions with the greatest delay were placed at the beginning of the assembler block, and after these instructions, we set other instructions that could be executed in parallel. The loading of coefficients and constants is done outside the loop, avoiding additional memory access. The processing of most routines is based on computing with 8-bit data. And as you can see in this example, we used these instructions for data packing, and then we can handle 4 pixels in one pass. And finally, results of these optimizations were obtained by measuring the performance of the graphic library using test programs developed by the authors of the libpng graphic library. Tests generally do some conversions between PNG and other image formats. And before using existing libpng tests, we created our standalone tests to verify bit exactness and acceleration for all routines. These tests have shown that optimized routines give bit exactness outputs for same inputs and acceleration of about from 35% to 80% depending on the optimized routines. After that, we used existing tests that check outputs bit exactness after image processing and have time execution measurements that is done in terms of seconds. By comparing results, we can see a significant improvement for each optimized routines as shown in table. And finally, we could say that the libpng library optimization for MIPS architecture described in this paper shows satisfactory results. In the meantime, we worked on optimization for zlib library, which libpng uses for compression and decompression, and we didn't get satisfactory results for the mixed DSPAC instruction set. Maybe further enhancement of the execution speed of the PNG image processing algorithm on the MIPS platform can be achieved by introducing support for the MSA extension of the MIPS instruction set that implements 128-bit wide vector registers that significantly increases the possibility of parallelization. Thank you for your attention. If you have any questions, please feel free to ask me.
Thank you for your nice presentation. So please, is there any questions? Don't forget unmute your microphone if you want to speak. Okay, so I have one question for you. If you mean that assembly language program which is written in assembler will be always greater speed for than C language, or that are qualifications of the programmer who can write programs in the assembly language?
Sorry, but could you please repeat your question? Because I have some sound cat.
The main cat is the program which is written in assembly language always will be speed more greater than you translate from C and optimize. It is always by nature, because assembly language is processor language, as I know. Oh, no.
Sorry, could you please repeat your question?
You compared C language program with assembler in line or
okay.
or assembler at all? Yes.
Okay.
Yes, and my question is, when you compare such programs, as I hope, assembler program always will be better than writing in C.
Yes, of course. Assembler program is always better than higher level language like C, and you can with your compiler you can get you can always get assembler code, but with our optimization you can get better results and better optimization.
So you proposed optimization is better than a programmer will write program in assembler. Yes.
Yes, of course.
Okay, thank you. Are there any questions? So thank you for your presentation.
Thank you very
Once
much.
again, stop share your screen and
Okay.
second presenter presents presentation.
Just to.
Okay, thank you. So the next presentation in our section is resource allocation techniques in cloud computing, a review and future direction. Presenter Muhammad Faraz Manzoor. As I can see, he is not arrived.
Hello, everyone. Hello.
Okay. Hello. So please share your screen and start your presentation.
Just give me a minute.
Yes, we are hearing you. Please share your screen and start your presentation. You have 15 minutes.
Actually, I was expecting the meeting at 2:30 Pakistan Standard Time.
Share your screen, please.
Yes,
we do not see your presentation. In Zoom, green
yes.
button.
Can you see now?
No. Select.
Just give me a minute. Yes.
Where are your presentation?
Now, can you see now?
Yeah. Yes. Now is everything okay? Please start.
Okay. My name is Muhammad Faraz Manzoor, and I'm doing PhD.
Start your presentation at the main screen.
Okay.
We know
my name is
PowerPoint, but do not see slides.
Wait, now, can you see slides now?
F5. Oh, okay. Now is everything okay? Let's go.
Oh, everything is visible right now. Okay.
Yes, everything. Oh,
okay. Okay. My name is Muhammad Faraz Manzoor. I'm doing computer science from University of Management Technology, Lahore, Pakistan. The topic of my research is resource allocation techniques in cloud computing, a review and future directions. First of all, the outline of my presentation is introduction, related work, research questions, noticeable techniques that we discover from this research, promise future directions, and conclusions. First of all, cloud computing, everyone is familiar with the cloud computing, and everyone know that is it a very important model to process data and execute computationally concentrated application in pay-per-use method. On the other hand, one of its very important component is resource allocation. And why resource allocation is so important? So that it can make the task to work efficiently and to finish it in the given time. First of all, introduction. Resource allocations is a very challenging task. Why? Because the resources are always available in a finite manner, and the demands of consumers are always increasing. So we have to allocate the resources according to their manner, and it has to be a cost effective. Why? The aim of resource allocation is to limit the overhead expenses that are associated with the resources and consumers' tasks. The aim of this research, we presented the resource allocation techniques in structured literature manner in the different aspects of the techniques. We have sorted the techniques in the 5 heads given that strategic, target resource optimization, and scheduling and power. There were few surveys available in this particular field, but what makes our research different from this is that the review proposed by the Lavania and Chuba in the field of resource allocation and resource scheduling is that they didn't propose the taxonomy in the particular field. On the other hand, in the work of Muhammadiyah, they also describe the resource allocation and monitoring, and they put a light on the very important issues, but they didn't evaluate the techniques they discussed in their paper. And on the other hand, Mr. Bhamani also provide the survey allocation techniques, but the problem was that they also didn't evaluate the given techniques in the particular field. Now the research question we have addressed in our paper are the significance. What are the significance of resource allocation? What are the already developed existing techniques in resource allocation in cloud computing? Also, there were few parameters considered, which has to be considered by the developers while developing the resource allocation techniques. We have also shortlisted and evaluate the techniques on these parameters, which I will explain in the future slides. And the future direction we have found in the literature. First of all, significance. What are the significance of the resource allocation techniques? According to us, that we have found in the literature, that resources are allocated to the tasks required by the consumer so that these tasks are finished proficiently. And how can we finish these tasks proficiently, given that the four parameters that are when the resources are assigned, how much time is taken, what is the predecessor actions, and what is the relationship of the predecessor between the resources and the consumer task. And also, what the resource allocation in cloud computing also includes the resource disclosure, choice provisioning, application planning, and administration of the resources. And in the end, and the most important significance of resources, that it has to be intelligent enough to make the decision that when resources has to be allocated, what resources has to be allocated, where resources has to be allocated, and how much resources has to be allocated to the consumer's task, so that it is complete on the given time. Now, focus of the techniques were, I have already discussed, that strategic target resource optimization, scheduling, and power. There were many techniques, so we have classified these techniques into these given heads and also subdivided further into given parameters. Now, every technique addressed different type of problems during their development. So there were many parameters, but what we considered that the cost, resource utilization, energy, workload, execution time, response time, and user satisfaction. These are the most prominent parameters that we thought that every technique has to address. Now, when we are talking about cost, in this paper, we didn't address the cost associated with the cloud service consumer, but the cloud service provider. On the other hand, resource utilization, every cloud service provider wants their resources to be utilized in a maximum manner. They don't want to they don't want to put their resources idle. And when a very important factor, energy, is that when you are living in a subcontinent like us, in Pakistan, India, or Bangladesh, the energy prices is very high there. So when we are talking about the resource allocation techniques and addressing the parameter energy, we want it to consume as low energy as possible. Workload, the technique has to be intelligent enough to shift the workload when the one resource is occupied maximally. And in the end, execution time, response time. Now, these are the parameters that are important for both point of view, cloud service provider, cloud service consumer, because they don't want to take the time in these parameters. And in the end, user satisfaction. Now, user don't bother that what is happening behind the scenes. They just want to be satisfied as much as possible. There were many techniques that we have discovered in the literature, but there were few noticeable techniques that every author has presented, and we have shortlisted them from our literature. For example, when we are talking about dynamic-based resource allocation techniques, Ms. Sarvasati proposed a work which is effectively efficient, but because it is consuming less cost, the utilization of resources were high and execution time was low. On the other hand, in the field of artificial intelligence, Mr. Liang also proposed a technique which is more efficient than others because the consumption of energy, workload, and execution time was low. When we are talking about virtual machine-based resource allocation techniques, Mr. Thamarai also proposed a technique which is cost-effective, response time and execution time of task is low. In the network field, Mr. Sun's proposed technique was also relatively efficient because the workload, execution time, and resource utilization was high. When we are talking about maximum resource utilization based techniques, there was a work of Mr. Volke which is more efficient because the cost energy was low and resource utilization was high. Now, when we are talking about quality of service, Mr. Lu has presented a technique which is more efficient because they have addressed both the perspective of the cloud service providers and cloud service consumers. There were few algorithms for scheduling which we also considered is very important. For example, priority-based resource allocation, in which Mr. Lee proposed a technique which is cost-effective and response time and workload was very low. Very famous resource allocation, very famous algorithm for scheduling is round robin, and it is also very prominent area in the resource scheduling techniques. When we are talking about it, Mr. Mishra proposed a technique in this field which is more suitable because of the resource utilization and user satisfaction was very high. In the end, power-aware resource allocation techniques was also very important. We have subdivided it into two fields, energy-aware resource allocation techniques and thermal-aware resource allocation techniques, in which the Mr. proposed a work which is effectively efficient because the cost, energy, and workload was very low. And in the end, the thermal-aware resource allocation techniques was proposed by Mr. Yaitsu, which has a low cost, low energy consumption, low execution time, and very high user satisfaction. Now, point to be noted when we are talking about parameters, it is not good when every parameter is high because we have arranged the parameters in a quantitative manner from 1 to 5. 1 is being the lowest and 5 is being the highest. When we are talking about 5, it is not good for the specific parameters such as cost, resource, cost, and energy. Because when we are talking about cost being is equal to 5, it means it is consuming a more cost, and same goes to energy. It has to be as low as possible. So it varies this parameter to parameter. In the end, the future direction. According to us, the resource allocation based tech has to be intelligent enough to map the workload and resources for the better scheduling of jobs. And we also find a gap in the artificial intelligence based resource allocation technique that it is not as much cost effective as it should be. So we thought that it has to be cost effective and it has to be developed in a manner that it is suitable for the larger systems. In the end, the network-based resource allocation techniques has to satisfy the consumer requirements more, and it has to reduce the communication cost by finding out the shortest path between the consumer task to the allocated resources. In the end, and the most important according to us, that it is very low, less power-based resource allocation techniques reviews are available, which are addressing the green optimization. In this research, we conclude that every resource allocation technique has to meet the suitable criteria, and those suitable criteria we have already discussed in this paper, that it has to address the cost, energy, response time, execution time, workload, resource utilization, and the service level agreement between both cloud service consumer and cloud service providers. Also, this study also helps us to conclude that the recent developments in storage infrastructure, networks, and wireless communication and virtualization have greatly influenced the research being conducted in the field of cloud computing. Thank you. These are the references that I have used in this research. Any questions?
Thank you for your presentation. Now, is there any questions, please? could you show one slide conclusion before that?
Sorry?
Could you open a slide before that conclusion? Yes, future direction. I want to, my question is, if you want to satisfy the consumer requirements and
yes,
also reduce the communication cost, I see that how you will try to satisfy that two requirements.
As it already as it is already labeled under the future direction, so I think it is the work for the future. And as long I am the PhD candidate and my comprehensive is just pending because of pandemic, so I will definitely work on that.
Oh, okay, thank you. More questions? Don't forget unmute your microphone if you want to ask question. Is there any question? No? Oh, so thank you for your presentation. Stop sharing your screen, please.
Okay.
Okay. The second presentation is technical threat intelligence analytics, what and how to visualize for analytic process, and I will make that presentation. I will share my screen. Okay. You see my presentation?
Yes, everything is okay.
Okay, thank you. So I am Evgeny Stoldinas and I will present that presentation. Outline: introduction, related service on visual analytics, methodology used in our analysis, challenges of visual analytics in the technical threat intelligence, and domain, and conclusions. So, visual analytics concentrates on using data visualization techniques. Visual data analysis helps to recover patterns and anomalies in aggregated multi-dimensional environment. The purpose of visualization is to help domain analysts in technical threat intelligence analytics to maintain security of hardware and networks by contributing to intelligent tools and decisions support frameworks. Besides, visual techniques have been utilized in cybersecurity domain. Visualization methods are especially advantageous for situational awareness and threat intelligence. Meaningful visualization of the security data enables to acquire beneficial observations that allows domain experts to make knowledge decisions. So, as based on related surveys on visual analytics, we found that about 130 works from period of 14 years, we found 130 works. Information visualization over 80. So the problem is actual, and we try to analyze that. Methodology used in our analysis were Bertin's semiotic theory of graphic, and that methodology has been extended by Moody to physics of notations, because Moody analyzed the use of visual notation consisting of graphical literals, their rules of composition, and assigned meaning for developing effective domain-specific visual languages. So, principles of physics of notation are as follows: semiotic clarity, there is mapping between graphics and semantic meaning. Perceptual discriminability, elements are clearly separable to view. Semantic transparency, visual elements suggest their meaning. Complexity management provides explicit tools to tackle complexity. 5, cognitive integration, the ability to integrate information across different sources. Visual expressiveness, visual variables fully exploited. Double encoding using text to duplicate visuals. Graphic economy, limit the amount of graphics. In cognitive fit, the ability to adjust for different tasks and audiences. So, the summary of our result based on physics of notations are shown in the table. We evaluate some tools selected from scientific papers for the criteria as good, average, bad, and not applies if there are any, if you don't found any information. The table continues here. We will also can see good, average, bad, and not applies evaluations. And the summary of our results we will propose in that table. So if we calculate good, average, bad, and not applies evaluations, we can define that average and bad is 30%, average, and bad 34%. At all, 64% is not good, but average or bad. So based on that analysis, we have formulated challenges in the technical threat intelligence domain as follows. The first, the collaborative visual analytics underscore the importance of sharing knowledge and sapience between collaborating technical threat intelligence experts. Heterogeneous data analysis, the creation of uniform interaction mechanisms to visualize heterogeneous data sources will remain challenging. Human factor also, effective use of visual variables that are highly influential for real-time data exploration tasks at now time. Privacy, visualization tools should guarantee the privacy of the user, reliability, threat and technical threat intelligence domain visually, which is essential in guaranteeing reliability and trust in visual analytics and decision support. Report generation is also challenge because report generation can provide interesting views into interesting patterns of knowledge discovered by threat intelligence analytics. Scalability, cloud computing and others, and also the explosive growth of information usable for technical threat analysis remain an enormous hurdle to visualizing the domain information efficiently. And usability is also a challenge because visualization should be well implemented and satisfying while ensuring efficient decision support. Main elements of usability such as familiarity, learnability, responsiveness, intuitiveness, helpfulness, and satisfactoriness must be guaranteed. So in that table, we show some of strengths and weakness of techniques for visualization for some elements that are widely used: scatter plots, clustering, time series, tree maps, histogram, and you can see that there are for technical threat intelligence data weakness, a lot of weaknesses for that mentioned visualization elements. Conclusions. So novel methods should be examined to visualize the fidelity and fullness of threat intelligence data. And we see that there are no standard design principles to support visualization of threat intelligence data. The enormous growth of network data translates in data visualizing problems using a traditional display screen with a constrained size and resolution. So comprehending large-scale data patterns require both visualization and big data analytics methods to achieve a high level of scalability and performance, which is especially important for recognizing large-scale cyber attacks in real time. And developing visual analytics methods that work efficiently with real-world data in real time remains a huge challenge. Any efficient visualization workflow should be based on a solid background, such as the model of visual analytics system, one of those depicted in the picture. So thank you for attention. If you have questions, please ask. Are there any questions for me? No. Okay, so thank you for your attention again. And now we will start the next presentation. The next presentation is continuity detection method in binary image signal. So Zdenek, please share your screen and start your presentation.
Okay, thank you.
You do not hear?
Yes, I am here. Can you hear me? Can you hear me?
Very simple.
Is it better?
Oh, yeah. Yes, now it is better. Share your screen, please, and start your presentation.
Okay.
Okay.
Good morning, ladies and gentlemen. My name is Zdeněk Macháček, and I am from Technical University of Ostrava from Czech Republic. And I'd like to present you the project task, which we work on it with our colleagues from Poland, from the Białystok University of Technology. And that our main task is continuity detection method in binary image signal. Let me say a few about our presentation outline. So the first, I like say you a few words about the project task and deal. Then I will speak about the principle of original blob method and about our innovative blob method. Then I will speak a few about our experiments, and I will show you the result from verification, and then I will assume all of information in conclusion. So the paper is focused on description of a new method, especially useful for other markering of continuities in binary image. This operation for part image recognition is known as binary large object, BLOB. Our research deal was to optimize the process for continuous area marking by an order number of detecting area. This type of operation is suitable for image pattern recognition or OCR algorithm. We tested and verified method algorithms by implementation in MATLAB software. We analyze and compare innovative method with original command method in different conditions with the time dependencies and memory size consumptions. As you can see on the images, the algorithm of the original command method is based on two path principles. The reference number of each separate object detected from the image matrix is calculating according to the local discrete convolution. And this Discrete convolution is given by equations with masks. You can see them H41 or 81, and the local mass is then gradually moved to the right and down for each pixel to analyze image. During the first computation cycle, all columns of the binary image matrix with the results of the local discrete convolution are transformed to the new ordering matrix by gradually browsing. Yes, you can see the second image in the process. A necessary remarking of each continuous object is presented by because of the raw object recognition algorithm. Neighboring pixels which are recognized as objects must be remarked from the elements located lower in the object table. Of course, these remarking processes are time and memory consuming. Innovative method is based on the only one pass principal algorithm, where is continuous area represented by group of pixels with a true logical values, which is progressively expanded by a local discrete convolution G, given by equation where H defines the local mass of the size for us 3 to 3 columns, 3 rows, H4 and H8. The local mask is sequentially shifted with a currently computed and analyzed pixel located in the center of it. Non-zero pixels in an actually computed local area are marked. The block process is repeated for all marked pixels in the image, expanding a continuous area. Yes, on the right side you can see then the result. Right here you can see the principle of developed algorithm, and it's proceed to the next pixel element when the pixel element in the binary image matrix is equal to the logical false value. The algorithm increases the order number, and the algorithm assigns the number to the pixel element when the pixel element in the binary image matrix is equal to the logical value, the true. Yes. After this process, the pixel element is marked and all neighboring points are saved in the stack. First in, first out. Right there, you can see the comparison which was executed on the two sets on the binary images. Right here, you can see the first set. It's a testing on the changing size of the testing imaging. Yes, there was is presenting the verification of the process's time consumption consumed depending on the size of the object area in the testing image. The testing set of images is represented by only one continuous area with the same relative complexity but with different object area size. The obtained results show that the innovative method algorithm is fastest compared to the original classical method algorithm depending on the object area size. On the other hand, you can see right here the obtained results which show that the innovative method algorithm is much more memory size consuming compared to the original classical algorithm depending on the object area size. Yes. And there is the other verification. It's about the time consuming depending on the number of the object area in the tested image. You can see that the size of them is the same. Yes, the obtained results show that the innovative method algorithm is faster compared to the original classical method algorithm, depending on the number of the elements. In the other verification, we focus to memory size, the detection, and the obtained results show that the innovative method algorithm is constantly less memory size consuming in comparison to the original classical method algorithm. Yes, there is the different axes for each of them. So what's necessary to say as conclusion, the innovative block method is more efficient solution in terms of the processing speed and more efficient for memory saving. If we will speak about the time consuming block method verification by different object area size is 8 milliseconds faster, more than 20% time saving. On the other hand, the memory consuming verification, it's the innovative method is same memory size for a small object, but for bigger ones, it's more than 6 times larger memory size in the new innovative method. What could be the problem for it? If we verify the time consuming by different object number, it was about 6 milliseconds faster, more than 15% time saving, and the memory size consuming was the approximately 3 times larger memory size for a new method if we recognize only one object, but if we recognize maximal 28 objects would be tested, it's approximately 9 times smaller memory size consuming. So that's our results. I can say that this method is suitable for the low power microcontrollers applications where we use this algorithm. And thank you for your attention, and feel free to ask me about the problem in this presentation. So thank you again.
So thank you for your nice presentation. Have any questions? So I have one question for you. Intel and AMD processors use stack last in first out. If you using for your method instead of FIFO-LIFO, maybe it's, you can get better result or no?
Yes, we not tested yet, but it's very good questions for the next our research for testing and compare these two methods. Yes, possible methods.
Yeah, it will be very interesting because LIFO is supported by processors of FIFA not. But if you take AMD another processors that support LIFO and FIFA, you can compare the results.
Okay, okay. Thank you very much.
Thank you for your answers. Is there any questions? No. So thank you again for your presentation. Please stop sharing your screen.
Okay, thank you. Bye.
Bye. The next presentation is formal algebraic description of a fog IoT computing environment. And the presenter, Pedro, please share your screen and start your presentation.
Okay, thanks very much, Mr. Chairman. Good morning to everyone. My name is Pedro Juan Roig. I'm coming from Spain, from Universidad Miguel Hernández. And this presentation is about formal algebraic description of an IoT fog computing environment. First of all, a small introduction, then a model overview, and then I'll present different scenarios, right? And finally, I'll draw some conclusions. Well, introduction. Fog computing is one of the driving forces in computing research nowadays. The development of fog facilities is key for the full-scale deployment of IoT environments by means of a range of technologies such as 5G or Wi-Fi standards. The target in this paper is getting a formal algebraic description of a fog computing environment, basically achieving a general expression for the migration of VMs belonging to users getting from cloud to fog, moving around the fog, and getting back to cloud. Well, as an IoT device moves away from the coverage area of host 1 and gets close enough to host 2, VM migration takes place, right? Well, as per the model overview, fog computing environment composed by a number of facilities considered as building blocks, aimed at hosting VMs associated with clients within the coverage range of the proposed fog domain. So if the client moves out of the coverage area of a particular building block, either its associated VM migrates to another one or it gets back to the cloud. For simplicity purposes, a linear setup is going to be considered, and also to keep it simple, client may only access the fog environments from the first block. Well, each building block will have a common structure, only one entry path coming from the previous block, only one exit path going to the next block, and one exit path going straight to the cloud. And we are just presenting two exceptions to consider. First, the entry path for the first block is from the cloud itself, and the last block only has one exit path going straight to the cloud. As per the nomenclature, we're going to say use variable f sub x, meaning building block x, r sub I, meaning entry point from channel I, S sub O, meaning exit point out of channel O to the next block, and S sub O hat, meaning exit point from channel O hat to the cloud. And we will be considering two atomic actions, read and send, meaning read, receive a message from a channel, and send a message through a channel. And we will be using different operators. So the procedure here is going to be the 4 steps. First one, applying the expansion theorem by Bextra and Klopp, then applying an encapsulation operator, then applying abstraction operator, and finally compare the model, the behavior of the model with the behavior of the real system. Well, regarding the behavior of real systems, let us consider that f sub n is a string of n boxes, being each box a single building block. Each box may be empty or otherwise full with one item. Initially, boxes are empty, so just one ball may be put in. Once a box is full, you may just take one ball out. If f sub 1 is full, no new balls may get into the system, and every f sub n being full may take its ball out of the system. So the notation for the real systems are going to be x sub I, meaning I items inside the system. So taking the example of just one building block, x sub 0 will mean an empty system, and x sub 1 will mean a full system. So with this consideration, let's start with the scenarios. Let's present the first scenario, meaning one building block. Here we have the schematic diagram, right? And the behavior in this case of the real system will be just an empty box, x sub 0. And if one ball gets into the system through channel O, we'll have a full box, right? Meaning x sub 1. And this box eventually will leave the system through channel 1 hat, right? Getting back to state x sub 0. So the description of the model will be this one, meaning that in the model, an item gets into the system through channel 0 and will get out of the system through channel 1 hat. Here we have the mathematical expression. And the finite state diagram will be like this, right? We have the empty system here. If an item gets into the system, here we have the full system with the item here, right? And if this item leaves the system, we'll come back to the empty system here. So comparing the external behavior of the real system, there we have, and the behavior of the model system, here we have, it may be seen that those entities are equivalent, right? So they perform the same operations. So it is clear that they both are rooted branching dissimilar. Hence, the model gets verified. Well, let's go for the next scenario, meaning two building block scenario. Here we have this schematic diagram and the behavior of the real system. Let's take an empty box like this, x sub 0. If one item gets into the system through channel 0, we'll have x sub 1, meaning one ball into the box, right? This ball may get out of the system, out of the box through channel 1 hat, or another new ball might get into the system through channel 0, meaning x sub 2, meaning two boxes, meaning two balls into the box, right? And at this stage, it is only possible that one ball gets out of the system through channel 1 hat or through channel 2 hat. So the description of the model, we're going to separate entity F1 and entity F2, or meaning block F1, block F2. So for block F1, just if an item gets into the system through channel 0, it may go to the next building block through channel 1, or it may leave the system through channel 1 hat. And for entity F2, if a new item gets into F2 through channel 1, it may eventually leave the system through channel 2 hat, right? So here we have the finite state diagram, right? At the beginning, there are no items into the system. If one item gets through channel 0, here we have the item, right? This item might move through from F sub 1 to F sub 2. Here we go. Here we have it. And it leaves space for a new item to get into the system. So here we have two items into the system. The thing here is that we have 4 internal states, 1, 2, 3, and 4, but externally we only have 3 of 1, 2, and 3. Why? Because if we have a look at these two states, externally are the same, because externally there is just one item into the system, right? It doesn't matter where it is, in which box it is, right? So we're going to consider just a canonical representative of the state x1, considering just the one where the item is rightmost, right? Because it leaves free space for a new incoming item. So with this consideration, comparing the external behavior of the real system and the behavior of the model system, it is clear that they are both rooted branching dissimilar. Hence, the model gets verified. Something similar happens with the 3 building block scenario, right? The behavior of the real system, here we have it, right? Just with new items coming through channel 0, and all the items just leaving through either channel 1 or 1 hat, 2 hat, or 3 hat. So there we have the description of the model, the finite state diagram, there we have it, right? New items coming in, and the items just leaving the system this way. So comparing the external behavior of the real system and the behavior of the model system, it is also clear that they are both rooted branching similar. Here, hence, the model gets verified. And finally, let's go for the general scenario, meaning any building block scenario, right? There we have it. And the number of possible states in this system goes from 0 to n, meaning external states, right? This is, there are n plus 1 states in all. coming from the one having no items inside all the way to the one being full of items. So for each of those states, there is a number of equivalent expressions denoting all possible combinations along all available building blocks, meaning just all the possible internal states equivalent to one external state, right? And those are given by the ith row, and the jth column of the Pascal triangle. If we take, for example, the second row, meaning the two building blocks, we have three external states, meaning the number of cells within that row, 1, 2, and 3, and just for the zero internal state, there is just one possible internal state. For the external state of just one, there are two combinations, right? And for the external state of 2, we have just one combination, right? So in this case, 3 logic rules may be spotted in the cases presented so far. For example, new item coming into the system. So if a new item comes into the system, it just gets attached to the first building block, right? Another logic rule may be in an item passing from one block to another one, right? So we have one item in one block, it will pass to the block I+1, to the next following block, right? And the other logic rule is an existing item going out of the system, right? If we have an item into the system in position I, it may leave the system, right? So there is no item in that position into the system. So taking that into consideration, after applying all the operators considered above, the relationship among all possible states and the number of items into the system goes like this, right? This is all equivalent, right? The external behavior of the real model and the external behavior of the model itself, right? So it is clear that they are both routine branching dissimilar. Hence, the model gets verified. And finally, conclusions. A formal algebraic description of an ad hoc IoT environment composed by n blocks has been done. The study has been carried out in an incremental manner, going from a system from 1, 2, and 3 blocks in order to induce a general expression for n blocks. In all cases, specification of the model has been undertaken, and in turn, verification has been achieved by proving that the external behavior of the real system and the model are routine branching similar, which has been done in all cases. So this is it. Thank you for your attention. And if you have any questions, please ask.
So thank you for your interesting presentation.
Thank you.
It's very interesting also. So please have any questions? So I have a question. Size of block is in your model evaluated, or it is not important?
Well, we just undertook just theoretical works, right? So in order to keep it simple, we just decided that in each block there is only one item at maximum, right? So we could say that, for example, a maximum of n, let's say a maximum of 10, 20, but the results would be basically the same. So just in order to make the right calculations and to keep it simple, we just decided that there is just one item at best, but it could be anyone, but right, with any other maximum capacity, the results will be the same.
Mm-hmm. But every block must be the same size, yes?
Yes, it could be the same, yes.
Or could be not the same size of block.
Well, basically, it could be different. I mean, it could be different because the important thing is that when the block is full, there are no more capacities. So taking this into consideration, it doesn't matter if the capacity of the different blocks are different. So the thing is, when a block is full, that's it. No more. There's no more space. So just the new items have to go straight to the cloud. That's it.
Okay. Thank you.
You're
Is there any questions? No. So thank you for your presentation once again. Please stop sharing your screen and we'll.
You're welcome. Thank you.
Yeah. So next presentation is a new classification approach with deep mask arc CNN for synthetic aperture radar image segmentation. And that presentation will make Ridwan. So please share your screen and start your presentation.
Hello. Can you hear me?
Yes, we hear you. Start your presentation. Oh, okay. Everything okay, please.
Okay. Hello, welcome to my presentation. My study is related with mask arc CNN algorithm for synthetic aperture radar image segmentation. And as an introduction, I want to explain to my study. In this study, a hybrid classification approach, which is combined with a more deep mask region convolutional neural network and sparsely driven technique algorithm, is proposed for synthetic aperture radar image segmentation. Firstly, we evaluated the STD algorithm for the initial step, and then we combined to this algorithm with mask arc CNN, and we evaluated a hybrid classification approach for image segmentation for synthetic aperture radar images. And as you know, synthetic aperture radar images are widely used in satellite technology, especially these images are used for a lot of areas, such as military for unmanned air vehicles or early warning systems. Is mostly used radar images, and because of this, segmentation methods play an important role for extracting the meaningful part of the SAR image. And SAR images have a high quality resolution and complexity, and because of this, separating to these meaningful parts is very difficult. And this complexity is a big problem for the image segmentation. And smoothed and uncomplicated SAR images help to more quality and high accuracy segmentation. And I investigated to the literature the most effective method for the SAR image, region-based segmentation methods, and this method is very useful for the SAR image. Instead of the whole image data set is tested, the most effective method is to analyze to a sample of the part of the image. As you see in the picture, there's a river in segmentation in here, and it is just the river fields are segmented from the image, and this is a sample of the region-based segmentation. And in nowadays, convolutional neural network is a very useful deep learning architecture, and it is used for the object detection and image segmentation. And when we investigated the literature, mask arc convolutional neural network is one of the usable segmentation methods, which is inspired by the faster R CNN algorithm in recent years. And mask arc CNN, especially, there's a good feature in the mask arc CNN. The instant segmentation is same field. The instant segmentation is a subfield of the semantic segmentation. Actually, what is the difference of the semantic segmentation? For example, if there is some meaningful part of the an image, the parts are divided as a whole in semantic segmentation. But in the instant segmentation, if there are the same meaningful part of the image in the image, the parts are divided separately. For example, in here there are a lot of persons in the picture, but by using the instant segmentation, these meaningful parts are divided separately, even if they are in the same class. This is the person class actually, but these are divided separately with the same, with the different colors. And there is a good feature in the masked RCNN algorithm. And I want to explain two related works for my study. Sparse driving distracting method is used in our study, and SAR images have a lot of speckle noises, and the noisy speckles of the SAR image constitute an enough scale for image segmentation. And according to this, point-weight mixed pixel similarity is a big problem with this in the segmentation process. Because of this, we note that the speckle noises should be reduced for a high quality SAR image segmentation. What is the STD method? STD method is developed for reducing the age and point noises of the SAR image with the L0 and L1 norms by using a single parameter and less execution time. As you see in the picture, this is the original SAR image. But when we filter to image by using the STD method, the edges are sharpened and also the speckle noises are reduced with this method. And this is a useful method for the image segmentation. This is the initial step for our study. And in the M-star data, we used the M-star data set for our study. And this data set contains the 100 SAR images with the different angles of the regions. And what did we do with this data set? As an initial step and as a initial hybrid study, we prepared with a different data set by using this method, and all data images are smoothed with the STD method for a quality segmentation. As you see in this here, this is the original data set, and we filtered to all images, and we created a new data set that is called M-star STD data set. And as a graphic, this is our proposed method. Firstly, we smoothed all images, the dataset image, and we created this STD database, and then we used the pre-trained backbone networks, and finally we used the masked RCNN repeatedly, and by using this deeper masked RCNN, we aimed to masked RCNN reduction of the masked RCNN losses, and I will explain to the algorithm step the figure. What is the masked RCNN losses? This is actually the another aim of our study is reduction of the masked RCNN losses. For example, if you see in the picture, there's a masking losses in here. This is the first losses, and there's a bounding box loss in here. For example, this is a row segmentation, but there's a row in here, but it is not segmented with bounding box, and this is a different box losses. And also this is a classification losses. For example, this is a terrain terrain field in our study, but it is not segmented with masked RCNN. And if we reduce it to these losses, we can obtain a high quality segmentation. When we say about the algorithm steps, I told about these steps actually. We prepared the M-star STD dataset, and we created the dataset directory system for masked RCNN algorithm. And when we observed the M-star dataset, the most observed fields are forests, buildings, roads, trees, and terrain fields. And we defined up to 5 class identifier for the masked RCNN. And first, for the initial step, if it is initial step, we set to the default backbone networks such as Inception Y3 or COCO or ResNet 50. These networks we use it, and if the algorithm and we train it to this algorithm for our approach, and until a good quality segmentation, we repeat it to this process for our study by using the mask RCNN algorithm. And when we say about the mask RCNN method, the deep mask RCNN is used repeatedly until a good segmentation. For example, we compare it to these backbone networks in our study. There are five backbone networks for our study, and we arrive at to most accuracy rates in the second time, but these methods are also can be also used a lot of times until a good quality segmentation, and we arrive to our good segmentation in ResNet 50 and COCO backbone networks. I want to show a few segmentation results in with different results. As you see in the picture, we use it and we compare it to these backbone networks in our study. Firstly, we smoothed all images with SPD method, and we executed the mask RCNN algorithm as a deeper, another expression repeatedly. We use it, and until a good quality segmentation, we repeated this process. And if we compare the original image, as you see in the picture, the most quality segmentation is in ResNet 50 and COCO models. Especially the road segmentation is very good for these models, but the others, for example, the road segmentation is not enough for our study. Because of this, we arrive to this good quality segmentation in these backbone networks. And as a feature study, by using this method, we can also execute this algorithm with another SAR image datasets, firstly. And secondly, in our study, we focused on the 5 different regions because we observed the regions in the MSTAR dataset: forest, building, tree or trees, terrain or road segmentation. And because of this, these class identifiers are extended with the different fields. For example, lakes, oceans, seas, city centers. We can extend it to these class identifiers, and this can be also made for the future work. And thank you so much for your attention. If you have any question, I can reply to your questions. Thank you.
Thank you for your nice presentation. So, please, questions? Is there a question? So I will ask a question. In CNN networks, one of the methods that is used, data normalization, because the forest buildings, that images has not the same data. Are you using data normalization methods, and if what methods are used? One of that is min, max, and others, as I know.
It's actually mask RCNN, especially also combined segmentation method, we can say. For example, I want to show For example, this is the region-based segmentation, and as a convolutional neural network, the mask RCNN is used for our approach because this is a very useful segmentation, and because of this, we repeatedly use this segmentation method for our study.
So you use masking loads method for that, yes?
Yes, of course.
For this for not the same objects.
Yes, we aim to these losses in our study. We aim to reduction of these losses. If you can reduce to these losses, we can obtain to more high quality segmentation, and because we aim process
and better results. Yes, in such a manner. Okay, is there questions? More questions, please. No. So thank you again for your presentation. Our session now is over. Well, thanks participants for participating in electronics conference. So I will hope that we will see you next year. So thank you. Our session is over. Bye.
Thank you. Thank you, Mr. Chairman.
Thank you.
Okay.
Bye.
Thank you. Bye.
Thank you. Bye.
Bye. Bye. All.
Bye bye.